Okay, so we got to logarithms and exponentials. Logarithms and exponentials. This is almost it's a very small topic and not complicated. The only thing we need to know is that if I have log a x is equal to y, it's the same as saying I have a to the power y is equal to x. So I'm going straight to the properties, and if I have log a, it must be 1 because it only makes sense that a1 should be a. If I have log a 1, this must be 0 because it makes sense that a0 be 1. And we have change of base. I say if I have log ax, I want to change to b. I'll say log bx over log ba. And if I have log a and there's f here, I don't just use simple implementation. If I have log au plus log av, this is the same as log a uv, meaning I'll multiply. And if I have log au minus log av, this should be the same as log a u over v. And if I have log a u to the power n, it's the same as n log au, meaning that I can drop the power. It provides for that. So powers can be dropped in that manner. Okay. Then as John did it. Okay, I think we can proceed. So these are the properties. Now after having all these properties, then what do we use them for? So just an idea now that we must be able to sketch. You can be asked a question to sketch e to the power x, or 2 to the power x, 3 to the power x, which must not be a hard thing. So for all the sketches of this, if the base is positive and the power is positive, your graph comes through this way, where this guy is 1. Simply because you are going to a table, and then you pick values. Say you pick -1, you pick 0, you pick 1. If I take to 2, I'll have 2 to the power -1, that is 1 over 2. I put there, where these are x and these are y's. If I take to 0, it will be 2 to the power 0, which is 1. I take 1 and 2 to the power 1, which is 2. Then you plug in your values, -1, 0, 1. So you see that it will make sense to follow that pattern. If the power is negative, substitute your same values and take your time. The graph will go to the left, but on top, it will pass through here.
Sorry. How did you find the one?
N number to the power 0 is 1.
Uh,
So you just take a 0 on the power, it becomes 1. So this is e to the power -x. That is e to the power x. The same one I said e, it is 2 to the power x. The same one I said e, it is 2 to the power -x. What you are saying is, as long as the base is positive and the power is positive, it will be the same graph. When I make the power negative, it will be going to the left, and even if I change the base, I'll have the same points. And then the other two will be the negatives. So you must be able to just have ideas on those in case you're asked. So the other one will pass at -1, and again we'll have this one. Now this one is the transformation of the one in black on top. So it will be -e to the power x. And the other one will come through this way, and so it will be -e, -x. Just like that. Okay, so proceed. Okay, so these are the 4 graphs that you expect on the exponentials. If it was logarithms, you do that, and it crosses here. That is y. This is x. So for logs, you change. Our functions are given in this form. Then if you apply ln, it will be ln, it will be ln. So when they ask you, they say y is equal to ln, suppose they say x. This is the same as saying y is equal to log e x. So you can change it to exponential. You say e to the power y is equal to x. Okay, so now you have to swap things. So instead of it being on crossing the x-axis, it will cross the y-axis. So it will go, the positive one will go like this, So this is y is equal to log ex. The same one is log ax. Yes, you want to go and sleep and find it tomorrow. It is uploaded. Then the other one, this is the negative case now. And what is negative here is a power. So we put a negative there. We have log ax, or y is negative log ax. So the other ones will go to the left, but for this one it's important just to know these two. It makes sense. Okay. Then this was just having ideas on the exponentials. Now that you have ideas on exponentials and you also know the properties, we can look at some equations on exponentials and logarithms. One equation on each. Equations. So an equation on exponential, find the possible values of x for which 2 to the power 2x plus 1 is equal to 3 2x minus 1. This is the same as 2x multiplied by 2 to the power 1 is equal to 3 2x minus 1. Again, because I can write this, I can write this as this per n or as per m. So I can write the 2x as 2x squared. In the 2 to the power 1, I can write it there. Then I bring this others to the left, and then that plus 1 is 0. So I'm trying to form my quadratic equation here. So I'll let p to be 2 to the power x, so that I have 2p squared minus 3p plus 1 is 0. Okay. Then I have the factor 2, product is 2, then the factors will be 2 and 1, but they must all be negatives. So I have 2p squared minus 2p minus p plus 1 is 0. Then we factor out 2p, we remain with p minus 1. Factor out minus 1, so that you have p minus 1 is 0. And so we have p minus 1 and 2p minus 1 is 0. So p is 1, or p is positive half. The p1 is 2 to the x is 1. The p is equal to half is 2 to the x is half. So the first one here, you can see that the only number that will give you the one on the right when you take it as a power of x is 0. But in case I don't know how to find it, I can apply the log to the base this number, log 2x and log 2, 1. Now from this one here, we set a number, whatever base, because now there's a 1 there, we get 0. So applying the same concept. On the other one here, again, on the left-hand side, is where I put the properties where I can drop the power. Okay, yeah? You can see there that is, property number 7 drops the power. So x can come down, and when I say log 2 is equal to, we said log 2 1. So 2 following the properties, it becomes a property number 2. So we get 1. So x log 2a property number 3. When there's a 1 there, we get 0. Then the other one, this can also be written as 2 to the power negative 1. So x is negative 1. So we have these two solutions. If we take them there, they must satisfy the equation. You try if they do. So this is one on the exponentials. You look for one on logs.
So if here like 3, so we're supposed to put 3 here.
So you put 3 there. Okay, we go to equation that was one equation on
Sir,
logs.
how did you find x is equal to 0 in the previous question?
You're just looking for, you just look for a number that when you take it as a,
What? What, sir? Sorry, sir.
what number can you take as the power of 2 and then it gives you 1? It's only 0. That's why it is the solution there.
Thank you.
No magic. I'm trying to look for a log equation, but I can't see any. But anyway, you guys must have a lot of them, so you must solve.
What I say?
Okay, there's one here. Log 3z. Log 3z is equal to 4 log z3. Solve the equation. You're solving for z. So first thing, just wherever it is here, without taking n to the other side, the only thing you do is you take the 4 to the power so that you have 3, or just there you leave it. Let's leave it there and change the base from z to 3. So we'll have log 3 over log 3z, and then we multiply throughout by log 3z. So we see that we're going to have log 3z squared is equal to 4. Log 3 is 1. So we have that. But this is just the same as if you take the square roots, you get plus or minus 2. Because you take the square root here, take the square root there, you get log 3z is equal to plus or minus 2. Implying that we have the first option, log 3z is 2, or log 3z is negative 2. Now for 2, you said you can raise 3 to the power 2 must be z, so that 9 is equal to z, or 3 to the power negative 2 must be z, so that z is equal to 1 over 3 to the power 2, which is 1 over 9. Logs, equations involving logs, equations involving exponentials, and exponential graphs and log graphs, and the properties surrounding O. So you can be asked a very simple question on the properties here. For example, write this guy A4 plus 2 log A3 minus log A6. Simplify and give your answer as a single logarithm. So you say this is the same as what? Same base, but they're adding. So it will be log A4 over, since they're adding, but anyway, before they add, you take your time. So you have log A4 plus log A, you take 2 as a square, then minus log A6. The next time now, the ones that are adding, you multiply 4 by 3 squared, that's 9, and then divide by 6 because you're subtracting. So it will become log A, 4 times 9, that is 36, 36 over 6, you get 6. This is a single logarithm. Another one is where now they'll ask you to split this. Split log A x to the power 3 over y squared z. Write it in the form log ax, log ay, and log az. So what you do is you say, okay, log a x to the power 3 minus log a y squared z. Then you come back and say, okay, this is just log a. The 3 comes down, we remain with x, minus, you open the brackets, it will become log a y squared plus log a z. Why are you putting plus but then the denominator? It was a product in the denominator. So you must show that. That's why I put the negative outside. Then now I'm coming to distribute it. So it will be 3 log a x minus, the 2 comes down, and I have log a y. Then I now split the minus log a z. So we have expressed it in those forms that they have asked. So just follow the question the way it has come, bit by bit. So we still have two sessions, one on differentiation, one on integration.
Oh,
Hello.
can we do the last question in the tutorial sheet on log for multiplication?
If I could see it, we could have done it.
I have a question. Is there no simpler way to solve those logs? Because now everything just... No,
Everything is what?
it just
This
looks
is
like
the
a
simplest
roller
way.
coaster.
This is the simplest way of solving them.
Where is it simple?
I mean, why do you think it's hard?
From the beginning, from log 3 is it?
You're not pointing anywhere. I just saw that there it's plus. It's no longer plus because we have expanded the minus, which is outside the bracket. I hope I got you right. So I don't have the Torah sheet out. I'll solve that part you asked me. Okay.
Can I read out the question?
Looks like someone has sent. Okay. The last part, meaning question 12.
The one on simultaneous equations for logs.
Yeah, that is question 12. We have log x plus y is 0. At the same time, we have 2 log x minus or is equal to log y plus 1. Okay. Okay, I've answered that. The negative went into expand. Now, when you ask, the other properties is that log 10 u is the same as log u. So if I see there's no base written, I can write it with a base 10 x plus y for as long as it is log. If it was lean, because log e is the same as lean. So where I see log e, I take lean. Now here we have this, which is the same as log 10 x squared is equal to log 10 y plus 1. So on the left, we say 10 to the power 0. 10 to the power 0 is x plus y, implying that 1 is equal to x plus y. So this is our first equation, is x plus y is equal to 1. We're looking for a second equation so that we make them simultaneous. Now, since we have log 10, it means that the inside ones are the same. So x squared is the same as y plus 1. The principles of log. So that another way of saying the same is you take what is on the right, you bring it to the left hand side. There it will be 0. So you're going to have log 10 x squared over y plus 1 is 0. Then you say 10 to the power 0 is equal to x squared over y plus 1. But 10 to the power 0 is 1. So you have 1 is x squared over y plus 1. You cross multiply, it will be y plus 1 is equal to x squared. Same language. So this is equation 2. X squared is equal to y plus 1. So from the first one, I can solve for x, it is 1. Let me solve for y. Y, it is 1 minus x. So when I come here, I will say x squared minus y minus 1 is 0, which will be x squared minus, what is y? Y is 1 minus x. minus 1 is 0. So I have x squared minus 1 plus x minus 1 is 0. So this is x squared plus x minus 2 is 0. So the product is negative 2 and the sum is 1. So the factors will be minus 1 and 2, 0. So x will be out, and I have x minus 1 plus 2, and I have x minus 1 is 0. So x minus 1 and x plus 2 is 0. So x is 1 or x is negative 2. Now I bring in equation what? Equation 1. Y is equal to 1 minus 1, which is 0. So we have when x is 1, y is 0. On the same equation, we take y is equal to 1 minus 2, which is 1 plus 2, which is 3. So when x is negative 2, y is 3. So these are the solutions. You can try them, that is if you want. And how do you try? You go back to all the equations must be satisfied. If x is negative, the log is undefined there. But there's a 2 the other side there which says that it must be squared. So it makes sense to have it there. It doesn't matter. Like that. Okay.
How are you solving that? I'm not sure. Do you know what to do?
So we had 2 equations, and from each we made 1 equation. From the first one, we made the equation 1, which is x plus y, which is equal to 1. By taking 10 to the power 0 is equal to x plus y. 10 to the power 0 is 1. That formed equation 1. The ones I've numbered. Equation 1 here. Equation 2. We first take that 2 to x. It becomes the power. So we have log 10x squared is equal to log 10y plus 1. Now because I have the same basis, log 10, log 10. So the inside things must be the same also. So I say x squared is equal to y plus 1. Alternatively, I could take this side, I take it to the left and have this equation here. Do the division, then I raise 10 to the power 0. I get things go like that. Then from there, I have equation 1 and 2. I use substitution. From equation 1, y is the same as 1 minus x. Then I substitute in equation 2. It becomes a quadratic. I find 2 values of x. Then I go to my substituted, to my equation 1, where I solved for y. Then substitute back the x values. Then I get the y values. In that language. So we are logging out and log back for further differentiation. So because I know you understand how to differentiate, we'll go straight to the applications of differentiation, then we look at integration. So let's be quick to log back.